focused, again, on Firebase, on applications, on building projects, you know, the fun stuff. And it's all fun, but that stuff is particularly fun because you get your hands dirty and really start building something. Hopefully you now all feel sort of prepared to, you know, really work on your final project in earnest. Hopefully you've all started on it. Realize that we now have 4 classes left, including today. Like, we're really rubbing up against the end here. In any case, today we're going to kind of take a bit of a U-turn, and we're going to turn back to some JavaScript like language stuff. Now this is like the more advanced stuff. This is, you know, this would be like an introduction to like advanced JavaScript, right? So you can think of the class we've done as sort of like beginner through intermediate JavaScript, getting familiar with it, getting to the point where we can confidently build stuff with it. If you were going into like an advanced class, we would probably start with some of this material, or this material would come early on in the class. So this is sort of building up the place for you to know where to go next from here, right? I wouldn't expect you to come out of today and Thursday, the 2 classes will focus on this stuff, you know, having it all completely figured out, but you should, you know what you don't know and know what's out there, and hopefully start mastering some of these skills. So really the core focus here is JavaScript as an object-oriented language. So if you remember all the way back to the first week of class, I talked about, you know, there's sort of two predominant types of languages. One's called a functional language, or functional programming, and one's called object-oriented programming, object-oriented languages. JavaScript just so happens to have the ability to use either of these paradigms. And up until this point, we've mostly been using what is more aligned with sort of a functional approach, right? Where our core unit of our programs are functions. These functions that we build and combine in interesting ways. There's another way to use JavaScript, and oftentimes these are used in concert, not sort of one or the other. But there's another approach to organizing programs, and that's object-oriented programming. So in today's class, what we're going to be looking at is, one, what is object-oriented programming just as a concept, right? Not even looking at it specifically in JavaScript. What is it as a concept in sort of general terms? And then we'll look at how to apply that in JavaScript, how to use those concepts in JavaScript. And then finally, we're going to look at 2 like pretty advanced topics that it's important to have sort of introductory level understanding of, you know, as you're leaving this class. And one is this, this keyword. And I'm gonna go into all the detail about this and what it means in all these different situations. But you know, again, like until you watch this and think about this several times, you know, it's a tough concept. So you know, we're gonna do our best to sort of start demystifying this and all that it means. And then finally, we'll look at something called closures, which is another core JavaScript concept that is used a lot, especially in large JavaScript applications. And it's really, you know, an important concept that hopefully we can start to dive into. All right, so without further ado, I guess, you know, we're not doing any review at the top of this class, but are there any questions that people have, you know, about stuff that we were working on last week, or, you know, the project or anything like that that I can answer right off the top before we dive in? Okie dokie. On Thursday's class, we'll have a little time for just like full course review as well. So we'll go back to some of the earlier concepts and just draw on them to make sure we still have all of those in our head to some degree. Okay, so let's talk about, so first of all, agenda today, you know, just these concepts one by one, and we'll be doing exercises throughout. But before we actually get to the JavaScript portion, I just want to talk a little bit about what is object-oriented programming. So, you know, as I mentioned, the core of it is really organizing programs so that the fundamental building block of the program, of being a function, seen mostly so far, is what we call an object. Okay, so we've encountered, you know, object data types in JavaScript, and this is related to that, but it's not exactly the same. So, objects here is like a construct, not an actual data type, right? So we're thinking about object as a construct when I talk about objects here in object-oriented programming. Okay, so what does that mean? So To first start talking about object-oriented programming, the place where we start is something called a class. Okay, so a class is a description for a category of objects. Okay. So the way to think about this is by looking at examples. So a class might be a person, right, or an animal, or say a shopping cart, or maybe a controller, or a model, or a view. Right, things that we've seen in our programs before. Object classes are really descriptions of real-world things that we take into coding. So real-world things, and these things contain two things that are properties and methods. We'll look at both of those. So we start at the class, and classes have, they're a description, so they contain several things. The first thing that they contain are properties. Okay, so a class can have properties. For instance, let's take a look at a person class. A person might have a first name property, a last name property, an age property, may have a list of friends property, et cetera, et cetera. You can see how this could continue. We could add a bunch of properties if we wanted to accurately describe a person. But these are, attributes of an individual. They aren't sort of descriptions of actions. These are just things that describe the person. The next thing that a class can have are methods. Okay? And methods describe the functionality of this group of objects. So if we're looking at this person example, well, a person can walk, a person can say hello, you can count the friends of a person. All of these would be considered methods of the person class. So all of these things are methods that relate to this class. Okay, so here is a visual example. We might have a class called car. Right? This isn't a perfect thing because this car should really be capitalized. Car, and that would have methods like refuel, get fuel, get speed, drive. Right? All of these are sort of actions that the car can perform. And it also has properties, or sometimes called attributes. This is sort of a concept that applies to many different languages. So every language kind of uses different words for it. But I call them properties. Here they call them attributes. Fuel and max speed. So a car can have an amount of fuel. That's not like an action, it's a description of how much fuel is in the car at this moment. So this is a class description. Okay? So the next step is we need to take, and one more thing that every class has is a constructor. Okay? A constructor is a special method that's used to build an object of this class, or to construct an object of this class. So if the class is a car, a constructor is like a car factory, right? It's going to take this description of what a car looks like, and it's going to churn out an actual car. So a constructor is this method that's building the object. All right, so now that we have the class, the thing that the constructor makes is called an instance of this class. Right? Or sometimes it's called just an object, but the more appropriate term is an instance. Right? So if a car is the class, an instance would be my Kia Forte that's sitting in my garage. Right? That's a specific car instance. It's not a description of a group of instances. Okay, so again, if the car is the class, then this is John's, I don't know what kind of car that is, and Jane's Mini and somebody else's Beetle, right? Like individual specific instances of this class. Okay, so object-oriented programming is a way of taking data and grouping it with methods. Right, that's really the key here. Is we take this data and we group it together with the methods that relate to that data. Okay, so not only does a car have fuel, but it also has the ability to use that fuel to drive, say, right? So it's a way of organizing data and functionality methods together. Call that encapsulation is a word that sometimes is used for that. Not especially important to know the word, but the concept is just that. Okay? So there's a lot more to OOP, as we call it, OOP, object-oriented programming. But this is sort of the quick rundown that sets us up so that we can start looking at how this is used in JavaScript. Any questions about this so far? Okay. All right, so we're going to continue using examples like person and car, because they're pretty good. But now let's take a look at what it's like in JavaScript. In order to do this, though, we're going to have to get the starter code for today's class. So go ahead and open up your terminal, and we'll sync up. Okay, so here I am in the terminal. First thing I'm going to do is CD to make sure I'm in my home directory, which I am. And then I will CD into documents, where I keep all the codes. And then I will CD into the class repo JSD2. And once we're in there, we'll go ahead and git pull to get the latest code. And then once we do that, I'm going to CD up one directory. And then I will make a dir inside of Jacob's JS repo, my name repo. And I'm going to call it class, what is today? 16? Thank you, class 16. And then after that, I'm going to cp-r from the starter code, so JSDC2 16 object-oriented JS starter code into my new folder, Jacob's JS repo class 16, and I'm just going to put it right in there. And then I'll change directory into my new starter code, Jacob's JS dir, or JS repo, class 16, starter code. Finally, once I'm in there, I'm going to subble space dot to open this up in Sublime. Okay. So there's just one file in here, OOP practice, OOP practice, and we're going to be working our way down through this as we go. So the first thing I want you to do, using just things we've talked about, only things that you know, I want you to write a function that takes two string arguments, or has two string parameters, another way of saying that, first name and last name, and it returns an object, a JavaScript object that has a first name and last name property that assigns those inputs to that property. So the function returns an object that has two keys, first name and last name, with these two inputs assigned to those keys. Okay? So only things that we've talked about, write this function, and you call it like, make person or something like that. So it takes two pieces of input, two string inputs, and returns an object. And as I give you these prompts, you'll see that each of these prompts is in that OOP exercise. So you can, like, we're not going to do them all at once. We're going to do them as we go. So this is just number 1. Okay, so the prompt here is to write a function. So the first thing I'm going to do is just kind of define the outline of that function. I'm going to call it makePerson. I think that's a pretty appropriate name. Okay, so the prompt here says the function should take 2 pieces of input, 2 arguments that are passed in, or parameters that we have on the function definition, and the names of those should be first name and last name. So where should I put those in this function? So I should make variables like this? Yeah. Okay. So I think what you're referring to is like if we were getting these things from like HTML or something, yeah. Right? So what we're doing now is not even thinking about HTML. If we just want to accept input into our function, right? How do we accept input into the function? Yeah. Right, exactly. In order to accept input into the function, just a generic function, not thinking about necessarily how it interacts with HTML, we have to add these 2 things into the parentheses here, right? And this basically says this function will now accept 2 pieces of input, one called first name, one called last name. Okay, now what do I do next? Did anybody get further than this? What's the next step here? There's probably several options. Yeah.
Well, I created a variable called makePerson.
Okay.
And I made that variable an object.
Okay.
And then the object I created 2 keys, one for first name, one for last name. I set them equal to the input's first name and last name.
Right.
And I just return that variable.
And then we just return that new person. Absolutely. Absolutely. It's exactly what the prompt suggested. So here we're creating this variable and storing inside that variable a new object using these curly braces. We're just creating an object. We're giving it 2 keys, one called first name and one called last name. And in the values at those keys, we're just storing the pieces of input that the user passed in. So here on the left, these are keys, right? These are keys to this object. Here on the right, this is referring to these parameters that were passed in. So we could write it this way. Another way we might have written this, just to show you an alternative way of writing this. Another way we could have written this is just not even create this variable. We could have just returned it directly like that, right? So anywhere where you use a variable, you could just put the thing directly. Saves you a little bit of typing. Okay. All right. So remember this, right? So this is a function that takes in some input and returns a new object, right? What does that remind you of when we talked about OOP, object-oriented programming? What does this remind you of? A function here that takes in some input and returns a new object. Its job is to create a new object here. Constructor, right? And you would think of this object as the instance.
Yes.
This is a good mental framework for how to think about a constructor, right? It's a function that takes in some input and returns a new object. Okay. Now, to be clear, this isn't actually a constructor. We're going to look at what a constructor really looks like. But this is how you should think about a constructor. This is essentially what it does. Okay? All right, so this is a segues into, in JavaScript, object-oriented programming starts at the constructor. Okay, so when you start defining a class in JavaScript, the way you do that is by creating a constructor. Okay. And so what do you notice about this? This is a JavaScript constructor. What does this look like? Yeah, what's different about it? Yeah, there's nothing different about this. It is just a function. But by convention, we capitalize the first letter to signify that this is a constructor function used to make new class instances instead of just a regular function. However, it is just a regular function, and if we left it lowercase, it would still work the same. This is just a convention that we use to signify that this is a constructor. So this is just a function right now. It doesn't do anything, but this is what a constructor looks like. Okay. So once again, best practice, and this is without any sort of room for interpretation. Constructor names should be capitalized, 100%. Every language treats class names this way, right? Okay, so we're not done. There's another piece that we need in order to use this constructor. So we've defined it here. We defined a constructor here. There'll probably be more in it eventually. But in order to use this constructor, well, how do we call a function? Anybody remember how to call a function? Yeah. Exactly. So we do that, we call it, but we have to add a special word before calling it when it's a constructor. And that keyword is new. Okay? So here we are calling this person constructor, but we're putting the new keyword in front of it. Right? And what that does is, since we're using this new keyword in combination with the constructor, it's going to create a new object and store it here in this variable called Jacob. Yes? Correct. So Jacob here is an instance of person.
It's interesting. If you look at a lot of Firebase documentation, they used to, in version 2.0, have you create constructors to access all of their API stuff. So that's basically what they were just doing. They were just creating a constructor off of a function based off of the script.
Probably so, yeah. We will see this all over the place. Yeah, question?
What happens if you don't use a name?
When you don't use a name?
With soul return, like when you don't use new.
Oh, don't use new.
Return an object?
It won't. It won't.
Okay.
It only returns the object, it only creates the object if you use it in combination with the new keyword. If you don't use the new keyword, it's going to behave completely unreliable. It's going to do something completely different that we don't probably want.
So by default, JavaScript functions, or I don't know, don't return objects.
Not unless you use, like we did in our code here, unless we do it explicitly, right? So the difference between the constructor and this function here, right, is here we're explicitly returning an object. The constructor, we don't have to explicitly return it. We use that new keyword instead. And that will do it for us. Okay? So if I were to log Jacob now, what I'd see is essentially an empty object, right? Just a new empty object. We haven't defined any of the properties or methods yet. All we've done is created this constructor for a new class, right? And actually, let's do this. Let's run this code in, I mean, I'm going to run this code. You don't have to. I'm going to run this code in the inspector, in the console, the JavaScript console. And you can see, what this looks like. All right, so if I were to log like just a JavaScript object like this, an empty JavaScript object, what I see in the console, it says object and then the empty curly braces, correct? If I were to do this, define this function person constructor, create a new person instance, and then log it, what I'm going to see is the same thing, the empty things here, but instead of saying object, it says person. Right? So this is not just any object, it's a person object. It was created using the person constructor. Okay. Right now that doesn't mean anything because we haven't given that any properties or methods or anything, but at least JavaScript is recognizing that this is a person object. Okay? All right, so we've successfully created our first class definition, but right now it's, like I said, super uninteresting. It doesn't actually add any properties or methods to these instances. Right? They're just basically objects at this point. So here's where we make it interesting. So this is basically the equivalent to that make person function that we did, where we take in 2 pieces of input and then explicitly return an object that has those as properties. We could do the same thing by defining a constructor. A constructor can take any amount of input using parameters, just like any other function. And then we assign the input values into the this object. So there is an object here, this, and we're assigning these values into it. Okay. So in this constructor, anticipating that question maybe, in this constructor, this is the new instance that we are creating. Okay. So in that last example, you saw that it just gave us that empty object. This is that empty object. Okay, so in a constructor, this means the new instance that's being created. So what we're doing is just adding some properties to that new instance that's being created. So this is how we define the properties of our class. Yes?
So do we still need, do we need the parameters in the function
Yeah.
for it to work?
Yeah, because if we don't have these parameters here, there's no way for us to actually put in a first name and last name into this constructor. So if we don't have those parameters, then there's no way for us to make like a Jacob person versus a Muhammad person, right? They're all going to have the same name or no name at all. Yeah.
So is this then reference to person, Jacob?
Right, so it's that new empty object that's being created when we call this function. So this inside of a constructor, this inside of the constructor refers to the empty object that's being created. Right, so again, if I were to now call new person and pass in a first and last name, and then log it, what I'd see is person and then this object with those things inside of it. In fact, let's just run that in the console here. So here we are again. Now we've got this function person that it's the same constructor, but now it takes these inputs and assigns them into the newly created object. And we're going to instantiate or create an instance of person and store it here in this Jacob variable. So if I run this, once again, I'll see person here, but now instead of an empty object, I see one that has the first name and the last name that was passed in. Okay. So this Jacob here becomes here, here, and gets assigned into this empty object. Okay? Okay. So what I want you to do is look at the next question in the OOP practice. And what I want you to do is take this makeCar function, regular function, that explicitly returns an object. And I want you to turn this into a car class, a car constructor that instantiates a new car object. Okay? So we're going to basically do what we just did for makePerson and the person class. We'll do that same thing for makeCar and the car class. All right, as I'm refactoring this and turning this into a class definition, as opposed to, a regular function that returns a regular object, the first step is I need to define a function, right? I need to define that constructor function. And what name should I give this constructor function? Car, yeah. The name of the class that we want to create with this constructor. Right? So the make car is a regular function that generates a regular object. Here we want to create a car class that describes what properties and methods eventually, once we get there, does a car have. Okay. Well, it's going to take the same pieces of input that we had in the make car function. So we'll still need a make, model, and year. And this is the function, so we're going to use these curly braces to encapsulate the functionality here. And then, instead of creating a object and assigning the values into that object, what are we going to do instead? Yeah, use this, right? So here we can use this instead, which is this implied new object that's being created with this constructor. Okay, so this new object is being created. We can, instead of using the new car object that we've made explicitly, we can use this sort of implicit this new object and assign the values in there. So this dot make is equal to make, this dot model is equal to model, and this dot year is equal to year. And that's it. We now made that constructor. If we want to use it to, say, create a Jacob's car instance, we could do that by, instead of just calling make car, we use the new keyword and the car function. And here I'll just pass the same arguments. Kia Forte 2014. Serve me well. Okay. And so now if we were to run this and then log Jacob's car, instead of seeing person, curly braces, in the description of all the properties, we'd see car, curly braces, in the description of each of the properties. So here we've defined a new car class. And we've also defined what are the properties that every car should have. Right? Well, it should have a make, it should have a model, and it should have a year. And probably some other things eventually, but in this example, that's all we need. Questions? Sweet. Okay, so let's talk about another little concept here. When we've been creating objects or arrays up until this point, we've been using a shorthand. Little did we know, unbeknownst to us, we've been using a shorthand, and that shorthand is called a literal. Okay. So when we use those curly braces, that's creating what we call an object literal. Okay. It just means it's a shorthand for instantiating a new object. Okay. It's a shorthand for instantiate a new object. Just like using straight braces here is a shorthand for creating a new array. Okay. So this is what we call an array literal, and this is what we call an object literal. We could do the exact same thing by using their constructors. There is an object constructor function that's defined in JavaScript, the language. And we can create objects instead of doing this by saying new object. And those two things are equivalent. So little did we know, we've been making objects of these using classes all along. We've just been doing it using the shorthand and not looking deeper and seeing what's actually underneath all of that. But an array is just a class of objects, right? It's a class of objects that is basically an ordered list of values. Not only are arrays a class of objects, but functions are a class of objects. Oddly, that's a little inception. Also, strings and booleans and numbers can be, but aren't always objects. That's sort of outside the scope of this discussion, but occasionally we use strings as objects, occasionally we don't. So we would never use like a string constructor. That would be a bad thing to do. Yeah?
Is that why you can do like string.length?
Exactly. So if we do string.length, what's happening underneath the hood is JavaScript is turning that string into an object just so you can do .length, and then it's turning it back into a string. It's actually a very interesting process. And the reason it doesn't always have it as an object is because the object is more expensive, is bigger than the string itself. So if it keeps it as a string, unless it needs to do something like .length or .indexOf or reverse or whatever it might be, then it's generally more efficient. So JavaScript underneath the hood will actually convert those things, called boxing, convert it to an object when it needs to. But it's not always an object. That's why it's not a good idea to use like new string. Even though you could, it's not a good idea to do that. So again, these two groups of statements are equivalent. These literals are just shorthands for doing constructors, for instantiating new objects. Another thing that kind of gets confusing when we're throwing this object word around, right, all the time, this thing here, the curly braces that we've been using up until this point, sometimes we call that a plain object. Or some people call it a POJO, a plain old JavaScript object. And this is an object that has basically no class, really. So it's an object of the object class, in other words. There's no special functionality here, no special methods or properties. It's just a plain object. Okay. And so when we made a car using the toMakeCar function, we were actually creating a plain object here, an object of the object class, because we were using these. By turning this into a constructor and a class definition, we're turning this from a plain object into a car object. So just a little terminology to unclutter our vocabulary here. This we might call a plain object, especially when we're talking about OOP terms. Once again, remembering that these two things are equivalent. Okay. Now, what if we have a variable, with the name like X, okay, that was assigned in some other part of our program? We're not actually sure what class this object X belongs to. Okay, it may be a car, but it might be a person. We're not 100% sure. Well, there's a way for us to tell. If you remember, when we were looking at other data types like numbers and strings, there was something called type of, and we could check the type of a piece of data. Well, when we're looking at objects, there's an equivalent function called instance of, which can tell us which class does this object belong to, or does this object belong to this class. Okay. So here, if we created an object using the new object constructor and a person using the new person constructor, we can see that my instance of object, so is my an instance of object, that would evaluate to true, because it is an instance of the object constructor. On the next line, is my an instance of person, that would evaluate to false, because my here is an object, it's not a person. Similarly, we could say, is Jacob an instance of person? And the answer, of course, is true. It was created using the person constructor. Okay. So instance of is a way for us to tell what class does this object belong to. Yeah?
What the real-life scenarios for using this is to maybe make sure that text field is plain text versus. Or
So a good example is, right, say we are in this situation where we don't know if it's of class X or class Y, okay, person or car. A car may have certain functions, methods, whereas a person has different methods. So before we can call the appropriate method, we need to know what class it belongs to. So that's a scenario where we might use instance of. Mm-hmm.
So if it's instance of this, then do that.
Exactly.
So it's like telling by its function what type of object.
Well, I mean, there's a little more to it than that. Underneath the hood, though, yeah. Basically, every object when it's created keeps track of the constructor used to create it. So when you're doing instance of, it's looking at this object's constructor and saying which constructor did it use? Oh, it used the person constructor. So that's how instance of works underneath it all. But basically, all this is telling you is, which constructor was used to create this object. Or what, in other words, what class does it belong to? Does it belong to the person class? Does it belong to the car class? Is it just a regular object? Does it belong to the object class? Etc. Okay, so now in the in the exercise, go ahead and tackle the next two questions. So there's another one that kind of does what we did last time, number 3, and then number 4 is using instance of to check the types of the previous 2 questions. Okay? So go ahead and look at numbers 3 and 4. Okay, so number 3 is pretty straightforward. It's just like the previous example that we saw. We're going to take this make_tweet function, which returns a plain object, right? An object using just the curly braces, a plain object here. We're going to turn it into a class definition. And we do that by creating a constructor. And remember that constructors start with a capital letter. So here we're creating a tweet class. Okay? This tweet class, as the make_tweet tells us, is going to have 3 pieces of input: a user ID, text, and tags. And now, instead of assigning those values directly into this object like this, we're going to use this keyword, this, which refers to the new instance that's being created. Right? So it refers to the new object that's being created. So we can say this.userID is equal to user ID. This.text is equal to text. And this.tags is equal to tags. All right. And if we then want to use this function, well, I'll create a variable called myTweet. And instead of just calling the function like this, or even like this, right? Instead of doing that, we need to make sure we use, because it's a constructor, that new keyword. So we're creating a new tweet with the user ID. We'll say 1, 2, 3, 4. Just use the text from above. This is my tweet, yay. Hashtag yay. And we'll store the tags in an array. Okay. So we've created now a new instance of a tweet. We've stored it in this myTweet. In other words, we've instantiated a tweet. Fancy word for saying to create an instance. So now this is sort of vague, but it's asking us to use instance of to check, to see what instance are these two variables, my tweet and Jacob's car, or your name car, whatever you use. What class do those instances belong to? Okay, so well, if I just want to make things that are true, I could say Jacob's car, instance of, what class does Jacob's car belong to? The car class. So that statement will evaluate the true. So if I wanted to, for example, if I wanted to use this in an if statement, I could do so like this. If Jacob's car is an instance of car, well now, since I know it's an instance of car, I know that it has, say, a make property. So I could console.log, oops, helps if I spell it right, console.log Jacob's car .make. Since I know that this object, Jacob's car, is an instance of this class, I know it has this make property, so I can safely log that make property. Now, 9 times out of 10, you probably will know what type the object, what class the object belongs to without doing this instance of check. But there are occasions where it may be one class or another. It's possible that comes up. Okay, so that's how we might check if it's a car. And we could do the same thing for tweet, right? So we could say, if we wanted to say, like, does the tweet, my tweet, belong to the tweet class? This would also evaluate to true. If we said car here instead, that would evaluate to false. So we know it doesn't have a make property, or we aren't guaranteed that it has a make property.
So we could use like equal signs. Is there a notation to say if my tweet?
If what you want to check is what class it belongs to, this is the operation to do it. Instance of, yeah. Now, here's another question. If we had used, instead of new tweet, we had used make tweet, the function that's defined right here, what would this evaluate to? Somebody said false? Somebody who said false, explain to me why.
One you haven't commented out, so.
Well, okay. Imagine this isn't commented out. Right? Not commented out. False is still the right answer. Why?
So when we're giving it all the same properties, it's not within class of
Right.
the properties.
What constructor did we use to make this object? You might be tempted to say none. And that, semantics may say that's right or wrong. But what we did was we used an object literal, which remember is using the object constructor, the new object constructor. So what we've done here is we've created an instance of the object class, the plain old JavaScript object class, right? So no, this object from makeTweet does not belong to the tweet class. It belongs to the object class. Okay? Not as helpful. A bunch of stuff belongs to the object class. We have no idea what properties or methods it may have. I could have a bunch, yeah. Mm-hmm. Yep. So here, up in makeTweet, remember that using curly braces, like we've done here, right? So we're using curly braces to create a JavaScript object. Remember that is equivalent to doing new object, right? So what we're creating here on line 36 through 40 is a new instance of the object class using that object constructor. Okay? So the tweet constructor is never involved in this transaction. Right? We're never using the word new with the tweet constructor at the same time. It just so happens that these things have the same properties, but they're not the same class because they were created using different constructors. Does that make sense? So what I'm asking, when I'm asking instance of, I'm asking which constructor was used to create this object. Was it the tweet constructor, capital T tweet constructor, in combination with the new keyword? Or was it the object constructor using an object literal or with new object? Does that make more sense? Okay. Cool. All right. Let me see what's next and decide. Yeah, I think this is probably, we're almost at an hour, so this is probably a good break in the just in the material. So let's go ahead and take an early 5-minute break, and then we'll come back and we'll start looking. Now we've got methods. We've got properties and constructors. The next thing we need is methods. How do we add methods to our classes? So we'll do that next after we take a break.
Let's figure out targets. That's authentication.
Yeah,
So as long as your settings are set up correctly, you can just use a flow with it.
so the thing is, I was looking at, I was looking at what they're doing, there's a, they just converted the platform to this, and there's like a lot of them, like you see stuff that's no longer supported. It's a great thing. So like their old way of authenticating, they have an old way of authenticating.
Yeah, you see it a lot.
And a new way, and the old way doesn't really work anymore. 'Cause I was looking at like
The old documentation is not in any way relevant.
yeah.
Version 2 and version 3.0 are opposites. Because you actually have to make an object instantiation. So you can use fire rates in the previous one, and this one you just call it as a.
Yes, that's so true.
See, that was my comment earlier. I am not being. Airbnb plus aircraft travel. For 4 nights, 5 days, $600. Yeah. Yeah. For 2 people. Yeah. Me and my wife gonna go pretend we're in the movies in New York. Like all those rom-coms that happen in New York, where they pretend it's not like balls fucking fall out. Oh yeah. Oh, serendipity with what's her face and yeah.
No, Serena lost.
She did?
She
Yeah.
was sick though. Like,
They already lost doubles, man.
In the first round. It's so sad. I'm heartbroken.
there's such.
I mean-
But I mean, our gymnastic team made up for it by kicking everybody's
Yeah, they
ass.
did insane. I just wish like gymnastics happened at prime time like swimming does. Cause I
I
want to see
agree
it.
because gymnastics, like, they do mind-blowing shit.
I love watching gymnastics.
How do they do that? I don't know. Probably
Lots of
the
practice.
entire lifetime worth of
Yeah.
practice, like anything else. I always thought, like, what do they do with themselves? Like, they've spent 16 years of their life, like, especially the women, basically doing one thing and one thing only.
Well, four events, but yeah.
Yeah,
Yeah.
for like one Olympics. What do they do is like they get.
I mean,
I
like,
it's an auto like admission to like a Harvard, like an Ivy League
I'm
school.
sure.
So you're like application. You're like I was an Olympian at
Yeah.
16,
they love that shit.
right?
I mean, it does prove like a certain level of work ethic, and
It
you
does.
know, like beyond a doubt, this person knows how to get stuff done.
Yeah. Is she? Famous people get famous stuff. That was ballsy of her though. You rewatch those YouTube videos about the girl who like broke her ankle and then like did it again and scored a perfect one for the gold. It was like 1996 or something. She like broke her ankle on the previous run, went back, did it again, got the score to win. And just like, yeah.
I don't even know how she's still walking.
I don't either.
I was she even run? I saw the video too.
No, you're not American. Damn. Damn, it's pretty cool. You see that? Boom!
Sometimes I get it.
Dude, he's warping my vision of politics. I don't even know if this
Swim says, I'm like, please stop talking about that. Stop.
Oh, what's he talking about?
He's just so fearful and terrified. I'm like, if anyone is going to be terrified, it's me.
Yeah.
All right. Okay, so let's get back into it. Actually, what I wanted to do first was just drive that last point home again. So remember what I said, the last thing we kind of left off on was, you know, if we use this tweet constructor, well, we call the resulting instance an instance of tweet, right? If we use the make tweet function, right, we call the resulting object that is returned from here, this is an instance of object, right? It's using an object literal, which is a shorthand for using the object constructor. Okay, so just as another way to illustrate this is I'll just do it in the longhand, instead of doing it in the shorthand, the longhand would look like this. I'd create some variable, I'll call it new user, or new tweet, sorry. And I'll use the new object constructor. Okay. This creates a new instance of the object class with no properties in it. I can then put these properties into that new object using dot notation. Oops. Oops. Tweet dot tags equals tags. And then I can return that new tweet object. Right. So this is the same thing that was there before. This is just a longer hand way of doing it, where here I'm explicitly using the new object constructor instead of using the shorthand object literal. Right. So we can see that the thing that's returned from here, from this function, is not a tweet, it's a new object. Yeah.
So when you use this, is there, like before you type the first this, is there already an empty object available for you to use? Or
Exactly.
is it generated?
Exactly. I mean, we can think of a constructor as basically being this, but this line here and this line here happen implicitly because it is a constructor. Right? So if you notice, if I take these two lines away and replace new tweet with this is the same thing as our tweet constructor. So if I take the return and the creating of the new object up here, the empty object up here, and change this new tweet to the word this, all of a sudden these are the same thing. So we can think of constructors as doing this part and this part for us. When
Is the topic considered a constructor?
oh wait, when it happens here, no. When it happens here, this is the constructor, right? And so this is a mental framework. This isn't exactly what's happening. This is sort of a mental framework of how to think about a constructor.
So function, the bottom one is a constructor and the top is not.
This is a constructor.
Okay.
This is not.
Okay.
It uses the object constructor,
It uses the object, but it's
not a constructor. Yes.
So this like creates some variable.
Right. So if we wanted to think about what is JavaScript doing underneath the hood, in order to, when we use new in combination with this function, we can think of it almost like this, okay? Now, this is not exactly right, so you can't actually type this, but this is how we can think about it. Essentially, when we use the new keyword, it's going to create basically a variable this that's like an empty object. It's then going to assign the things inside of it, and then at the end, it's going to return that thing. Okay, so this is how we can think about a constructor. But once again, when we use the new keyword, this part and this part happen automatically, and we don't actually add those lines. Also, if you try to create a variable named this, that's going to probably do something weird and not work. Okay, make more sense?
Yeah.
Cool. All right. So now we've got constructors. We've kind of ripped them apart. We've got properties now, like first name and last name, or make, model, year. All these things that are just data stored inside of our objects. The next thing we need to do is we need to add functionality to these classes. Okay. So here is sort of a naive attempt at how we might do that. Okay. Very simply, here we're creating the properties. This is what we've done so far. Well, we could do the same thing for another property and store inside of that property just a function. Okay, so we could have this function called stored in the property say hi that logs, hi, my name is this dot first name plus this dot last name. Okay, and we know what this dot first name and this dot last name are because we've assigned them up here.
It seems like this acts completely differently
Yeah.
than if I were to use it traditionally, I say traditionally, but like in a jQuery sense.
It does. It absolutely acts completely differently than this does in jQuery called event listeners. It does. And I'm going to go through after we finish this object oriented stuff, I'm going to go through like 5 rules of how to figure out what this is, because it means different things in different contexts. So yes, but in this context, this is this new object instance that's being created.
So I just assume, so I mean it's kind of similar because basically what this is doing is this represents whatever the new variable you're using. So it kind of puts wherever new was in this. And
Essentially.
So it's variable dot first name equals first name.
Correct,
Like
correct.
that's all. So I mean in essence it's almost like that.
It's similar, but it is different. And we'll look at all of those cases in a few minutes. Okay, so remember I said naive attempt. So we could do this, and this would totally work, right? We could do this, and it would totally work. And then we could do, I'm just going to take this into the console and demonstrate. So we could take this and make this our constructor now. It not only has these 2 properties, but adds this method like this. We could do this, and I could create a variable Jacob equals new person. And we can see this person constructor, it still just takes 2 pieces of input. So I could still just do Jacob and Friedman. Okay, and so now this Jacob instance, not only does it have a first name property, right? Can everybody see this? Oh,
Yeah.
Too big. There you go. Not only does it have this first name property and a last name property, but it also has a say hi method. And I can call that method, and it will say, hi, my name is Jacob Friedman.
Why did it also pass on the phone?
Yeah.
So this is because console.log returns undefined. So yeah. If you look at this function up here, it's logging to the console, but this function here returns undefined. So it's just showing that undefined return value afterwards. But you can see it's running that function. So here in our constructor, not only did we add these 2 things as properties, but we also added the say hi key and stored in there a function that does this console logging. Hi, my name is this dot first name plus this dot last name.
Okay, so even though say I wasn't a key before writing that method, sort of adding that into the object.
Yeah, we've made a new constructor, right? So that old person constructor, we're iterating on it. This is our new person constructor, right? And we're adding this key, we're adding this key, and we're adding this key to this new instance object.
Okay, so you start off with an empty object,
Mhm.
and this new key is whatever.
Exactly. Yeah, it's important to point out these keys don't have to line up with the parameters necessarily. I mean, oftentimes the properties do because they derive themselves from this input, right? The input is specific to the things that are going to be stored in this object. However, they are independent, and we can call them different things, and we can have, as we can see here, more properties in our new object than parameters to the constructor.
Just by using this.
Yeah, we could add, we could say, for instance, and it's not letting me type there, but we could say, ooh, you have to shift in here, believe. Yeah, we could say this dot, foo equals bar, or whatever, right? There's no restriction to how many keys we can and can't add to this function. It's just an object. Okay, so again, this is one way we could do this, and it will totally work, as we saw. It totally worked, but it's not the best way.
So you're saying it's
I will describe why. Yeah. It's not the best way. Well, it's naive because there is a slightly better way of doing this. Now, there are some situations where we might want to do this way, and I'll talk about that later. But in general, we're going to use a different approach. And that approach involves something called an object prototype. Okay, before you look at this code, let me describe sort of from a high level what an object prototype is. Okay, so if you imagine this factory analogy, right? And it's a car factory, and the job of this car factory is to churn out new car instances. That factory may have some prototype car that it uses as a model for creating the new cars. Okay? So it just so happens that a constructor can have something that we call a prototype that it bases new instances on.
It's kind of like a custom template.
Essentially, yes. It's like a template for an object. Or,
All cars are going to have full wheel with a steering wheel.
exactly.
But then you're gonna make it into a
Perfect. Yes, that is exactly right. That's exactly the right way to think about it. Right. So exactly what you said. Things that are consistent between instances, like for instance, a car has 4 wheels, or a person belongs to this species Homo sapiens. Those things are consistent between the instances. We can put those things in the constructor's prototype. Okay, so here we've defined, again, our person constructor, back to the simple one with just the 2 properties. We can then add properties to that person constructor's prototype by saying person.prototype.whatever property we want to add. In this case, we're adding one called species, and we're saying that the species of a person is Homo sapiens. So now we can create this new person object the same way as before, and if we do Jacob.firstName, we'll see it's Jacob, just as we'd expect, but we can also do Jacob.species from the prototype, and that will show Homo sapiens. Yes?
So does that change the actual job description? Like, does it add that line into the structure?
Does it change the JavaScript?
Like, how does it, when you create a new person, and you do person after a type of species, where is that change recorded?
I will show you. So what's going on here? Okay. So basically, what's happening here is when we use dot notation or bracket notation to look up some property on an object, say species on a person object, it'll first check that instance. Okay. If it can't find it there, it will look at that instance prototype and see if that property is defined in the prototype. Okay. So here, the instance we know has a first name and last name. We didn't define the species. We didn't say this.species equals. We didn't define it on the instance. However, that instance prototype has that species, and thus, when we use dot notation, it will return the value from the prototype. Okay, so let's look at this visually. I think it might illustrate it a bit better. So here we have the person constructor, right? So here's the person constructor, and it defines basically 2 properties, the first name and the last name. Okay, just as we saw in the previous example. We've then defined, almost a bad thing, we then defined a person prototype. So we've attached a prototype to this constructor, and we've given that prototype of a property, species equals Homo sapiens. So not only are we giving it a property, but we're defining it as well as a specific value, here Homo sapiens. Okay? Now, when we use the new keyword to create an instance, okay, so new person, we'll create this Jacob instance down here that has these 2 properties with the values assigned now. So first name Jacob, last name Friedman. Okay. And this instance has a connection to the prototype from which it was created. Okay, so it has this connection, this sort of invisible arrow here, pointing to the prototype from which it was created. Yes?
Is the prototype here like local characteristics that we're going to find on all of the things there that constructor, like your CSS class or something?
I mean, that's a good analogy. That's a way to think about it, right? So anything that's in the prototype will exist in every single instance of that class. So if we add the species to the prototype, every person will have a species Homo sapiens now. So yeah, you can think of it as a way to modify globally all of the instances of this class.
Sorry, question.
Yeah.
So, is it possible with an instance to alter the species, even though all the rest of the code is
It totally is. This is one of the reasons why JavaScript is such a dangerous language at some points, is because it is possible to modify the prototype. Not only can you modify the prototype of classes you defined, but you can modify the prototype of classes defined by, say, the JavaScript language. So I could change what array.forEach does by saying array.prototype.forEach and changing what it does. I can completely change the functionality of native JavaScript things by modifying its prototype.
about the reverse, like an individual instance is changed so that it's different from all
Mhm.
instances.
If I try to update something on an individual instance, it won't affect other instances of that class. So if I tried to change the species of the Jacob instance, that wouldn't affect other person instances.
Okay, so that would mean everybody else in the room is the same thing except.
Except for me, I'm Martian. So.
Okay.
Yeah. So here's what happens, right? So when I say Jacob.firstName, JavaScript looks in the Jacob instance for a property called firstName. It's going to find it, right? It's going to find this property firstName, and it's going to give us the value that's stored there, Jacob. When I do Jacob.species, JavaScript is going to look in the Jacob instance for a property called species. It won't find it. Species isn't defined on the instance. So what it will do, it'll follow this invisible arrow up to the prototype, and it will find it in the prototype. And thus, it will give us the value Homo sapiens. And if we create another new object, this time a Jane instance, that will also have a link to the prototype.
So like if you had put a mark down, sorry, the next one. Like if you had put a mark down, it wouldn't bother at all.
Exactly right. Exactly right. So if I said Jacob.species equals Martian, then all of a sudden this instance has the species property, and it's not going to even go and look at the prototype.
It's missing it.
Correct. That's exactly right. Yeah.
It would be Jacob.species.Martian equals Martian. Only local to Jacob.
Correct. So just to illustrate what we're saying in words, let me use a person. Do I have a person? Yeah. So if I have a person constructor, takes a first name and a last name, and it then stores this dot first name equals first name, and this dot last name equals last name. Okay, and then I was to create an instance. Oh, and then I define on that constructor's prototype, the prototype it uses to create new objects, a species equal to Homo sapiens.
You don't want that inside your function.
No, it can't be inside the function. It has to be stored. You have to update the prototype after that constructor's been defined. because before the constructor is defined, person isn't anything. We can't refer to person. So then we would create an instance equals new person with those two properties. Actually, let's just take this all the way. I'll make another instance. Jane is another person with the name Jane Joe. I'm very creative. Thank you. Okay, so now if I were to do Jacob.species, if I were to log that, say, it would be Homo sapiens. If I were to do Jane.species, it would also be Homo sapiens. Okay? Now, if I were to say Jacob.species equals Martian, okay? Now, all of a sudden, the Jacob instance.species is equal to Martian. However, the Jane.species is still equal to Homo sapiens. We haven't modified the prototype. However, if down on this line, I were to take that person prototype, and redefine the species, the Martian. Well, now Jane is also a Martian. Jane.species is now also Martian because I've changed the prototype.
So if on that line it said Neanderthal,
Ah, great question. No, because the Jacob instance still has a species property, Martian. So the Jacob instance would stay Martian, but Jane would then be Neanderthal. And any other instance that hadn't defined a specific property. Okay, so generally speaking, there's a lot of rules here, but generally speaking, we use the prototype when the thing is going to be consistent across all instances of this class. Right? So in the case of person, all person objects should have this species. Now, there's nothing that's stopping us from changing that, but in general, we use this method, this prototype method, when we know it shouldn't change across these objects. Or maybe a caveat to that, it shouldn't change in a large group of these things. Like maybe certain ones will override it, but the vast majority will keep it consistent. Question to that?
Would you ever really want to do that?
Would I ever want to do what?
Wouldn't you rather just, if you at some point in your program that you were going to have your main data type change class object, would you want to protect that and just say this stop or species?
Totally. That's a better approach. Totally. Yeah. It is important though to illustrate this because sometimes people do change these things, and you'll see programs that do change them. So it's good to know those rules. But generally speaking, yes. If it's going to be variable across instances, just assign it in the constructor and make it a regular property. Good point. Yes.
So I hear this question, but if you assign species to, so you have that assigned to one of the same things, and then you change Jacob.species to something, but then you change Jacob.species to undefined, does it return undefined, or does that then grab from?
I actually don't even know the answer to that. Let's find out. I don't.
Assuming it checks if it's undefined or not.
Well, yeah, I would think that's the case, but I don't actually know the answer to that. And I find that a very interesting question, so I want to know. So if we define this class here, function by person, and then we create the Jacob instance. Oh, it's not new Jacob, new person. I'm going to short circuit a bit. So if we said, and then, we also have to say, oh yeah, we did that. So now if we said Jacob.species equals undefined. Okay, so now what is Jacob.species? Will it use undefined or will it go to the prototype? I do not know the answer. it's going to be undefined. But as soon as we assign it any value, including undefined, into the instance, it's going to retain that value.
How does it? Like, how would you evaluate whether something exists or referring?
Because there's a way to say, does a property have a key?
Oh, I see.
So it says, does it have this key species? And if it does, give us that value, even if the value is undefined. Or no, or anything else.
So by defining the species, you define a key.
Exactly.
And it went from 0 data on the instance inside the array to some data that you know.
Exactly. So again, once we make this new one, the same thing happens for every instance. The first name it can find, if we look for species, well, the species isn't there in the instance, so it'll go up and look in the prototype. Yes?
Let's say I wanted to know, for something, I know the Jane or I know the Jacob. So I can get the class object from that. How would you know the prototypes? Is there a code for it? Let's say I knew the Jacob object, but I wanted to know the class. Maybe the code was so big I didn't get it.
Right. So if you know the class, if you know what constructor is used, by definition, you know what prototype was used to create it. Because the prototype belongs to the constructor. Right? So if it was created using this person constructor, if it's an instance of person, it must be associated with the person prototype. Does that make sense?
Yes.
And then,
because you can change the prototype. It seems like you can have different prototypes.
no, you can only have one prototype. And when I update it,
You can have one prototype, but so if I just type in person.prototype, that's species.
Mhm.
That's not a species prototype.
yes, yes.
The person.
Right, because remember the prototype is an object itself. So we can have more than one thing in there. We can have species, we can have other things, number of legs, number of things. So all of those things can be stored inside the prototype, not just one species property. We'll see that in a second. Yeah.
Sorry, last quick
Yeah.
question. If you just console log an object, does it list the prototype attributes as well, or?
No, I mean, it doesn't do it obviously. There's a way to find out in the console, but it's not going to show it on the top level like it does the name of the constructor. No, it won't do that. All right. If you have more questions about this, feel free to drop them in the parking lot. That's why we have that channel, to kind of keep the conversation going. So, if you're still curious, please do ask. All right. So again, just to re-emphasize, we use the prototype when we want something to be consistent across all classes, all instances of a class. Okay? So we can use that, this is the same as above, we can use that in lots of different situations. So if you look at the next exercise in the OOP practice, you'll notice there's a car constructor there. What I want you to do is to take the parts of this car constructor that are consistent and instead use a prototype for those consistent portions. Okay? So if you'll notice, some things are consistent across every car instance created with this constructor. So let's take it out of the constructor and add them to a prototype. So go ahead and do that. It's the next question on the practice, which I believe is number 5, maybe? Yeah. Yeah, 6, number 6. Yeah. It's far outweighed by the cost of storing the number 4 in every instance, or the Homo sapien string in every instance. Yeah, it's a way of sort of not duplicating data in a program. So if we have that Homo sapien once in the prototype, we don't have to copy it once for each instance that's created. And so that really dramatically reduces the size of that. So that's where the cost savings comes. Okay, so we already have a constructor here, so I'm just actually going to uncomment this and use this one. Now the key here is to identify the portions of this constructor that don't change from instance to instance, right? That are invariable or consistent between the different instances of this class. Okay, so obviously these three things, make, model, and year, these are variable because they're based on inputs. Right? So these things will change from instance to instance, depending on what's passed in. However, it looks like every single object created by this will have a number of wheels equal to 4, and will have a description, a wheeled self-powered vehicle, motor vehicle used for transportation. Right? So these two things we've identified are consistent across instances. Okay? So instead of defining them there, I'm going to add them to the car constructor's prototype. And I can just do that by saying car.prototype number of wheels equals 4. And I can do the same for the description. Car.prototype.description equals, and I'll just copy that from up here. Right? So now if we were to create, copy mine from up here. Now if we were to create, using this new constructor down here, oops, too far, a Jacob's car instance using this constructor, well, not only would it have a make, a model, and a year, but that Jacob's car also has a dot number of wheels and a dot description. Okay.
So if you were to console log it, it would return.
Yeah, so I could console. Oh gosh, wrong keys all around. I could console log Jacob's car dot number of wheels. How did I do that? Number of wheels, and that would log to the console the number 4.
But if you,
Go ahead.
if you just did Jacob's car with no dot,
I would only see
here,
these things. Now, if I dig a little bit deeper, dug a little bit deeper into that object, I might be able to find the parts of the prototype, but it's not going to be immediately obvious that they're there in the console. Question?
Do you have to add each prototype to be separate?
Yeah, that's typically the way it's done. You could potentially, instead of doing this, say that the prototype is equal to an object with 2 keys, number of wheels and description, but we shy away from that because you might update the prototype in different places. So it's not generally a great idea to reassign it. It is possible, yeah. Anything is possible. Question?
So objects have, they're like their own prototypes, that's where like all that stuff comes from? Like Lake and stuff, that's where it's
Yeah.
in there already?
Yeah, exactly. So the object constructor, big O object constructor, has a prototype. And you get things like, for instance, every object has a function called, or a method called toString. Or the array prototype has something called length, or something of that nature. There's you know, those constructors themselves have prototypes. Yeah.
That's where all that stuff comes from.
That's where all that stuff comes from. That's automatically there in JavaScript. Is that that class is prototype? Yep. Very cool. Clicking. I was gonna say something else. Oh, the question was asked like, why we mentioned the first approach as being naive, right? As doing this dot when it's consistent as being sort of like a more naive approach. Why is this better? Well, the reason this is better is because rather than having to store the number 4 for a real self-powered motor vehicle, et cetera, that whole string, rather than having to store those in every instance of this class, we only have to store them once in the prototype. And this will greatly reduce the memory we use in our program because we're not copying that string into every instance of this object. Right? We're just storing it once in the prototype, and then we can go find it when we need it. So that's why this is the better attempt. So not only can we store, consistent properties this way. So here we're doing like consistent properties, right? Number of wheels to number 4, that's a property, you'd say. We can also use this to add methods. And this is how we typically add methods to functions, to classes. So we have the constructor up here, person, same as we've seen it before. And to define, instead of saying this.sayHi equals some function, instead of doing that, we're going to add the sayHi function to the prototype, to the object's prototype. Because this function is the same for every person object. So for every person instance, this function is the same. It does the same thing. Questions? Okay. So we're going to do another quick little exercise. If you look at the next one, number 7, there's this function make_to_do_list, which returns, as you can see, a plain object, an object of the object constructor. We want to turn this into a to-do list class. Okay? A to-do list class that uses a to-do list constructor and a prototype on that constructor. Okay? So go ahead and see if you can do that. We're going to convert this into a class and a prototype. Yes?
What shortcuts and select to get
Yeah. There's a shortcut if you want to comment or uncomment a huge block of code like this. I can highlight all of those lines, and then on Mac I can hit Command/, and that will uncomment them. I think on Windows it's probably Control/, and I can do that either direction too. Well, yeah, it'll save you time over that method for sure. Okay, so I'm going to start by just defining a function that is going to be my constructor. And it's a constructor for a class called to-do list. I know that it's going to, we're going to follow the same basic model here, and I'm going to take one piece of input that's a parameter called tasks, probably like a list of tasks, an array of tasks. And now I've got the skeleton here of my constructor. The next thing that we might do is take a look at this, this plain object that is returned by make to-do list, and we need to determine which things of these are consistent between every time this function of call is called, what things are consistent, and which things vary based on the input passed in, right? So which things vary here, and which things are consistent. So what things here vary based on the input passed in? Yeah, the tasks change, right? So the tasks come from input here, and they're stored in the tasks key. So the tasks of each to-do list will be different. Right? So those things vary between instances of the to-do list class. So right away we know that in order to assign the tasks to this instance, we're going to use this dot tasks equals tasks. Okay. Is there anything else here that varies between instances? Yeah, exactly. No, everything else is consistent. Every time we run this function, it'll have a name to-do list. It'll have a function log tasks that is defined in this way. Every time it'll have an add task function that's defined in this way. The rest of these keys and their values are consistent for every instance of our to-do list class. And thus, for all three of those things, we're going to use the prototype in order to assign the values. So our constructor is done. There's only one thing that varies in instance to instance, and that is the list of tasks. The next step is to start defining properties on the constructor's prototype. So the first one we've identified is name. The name is consistent, or we've defined it to be consistent, on every instance of this class. Okay. Well, we got that. The next thing that's consistent is every instance of this class. Oops, not to-do list, sorry. Every instance of this class will have a method or function. We call it a method when it's part of a class. We'll have a method called log tasks. In order to assign the value, I'm just going to copy it from up here. Okay. So now every to-do list that we create will have both a name called to-do list. It'll also have a method called log tasks that will log each of those tasks to the console. Finally, we know that every instance of the to-do list should have a method called add task is defined as follows. Oops. And comment those, tab them. Okay. So now we've converted that regular function called make to-do list into a class definition that defines properties that are consistent, and methods. Yes?
Because each log task, add task are now broken out with a semicolon on the end.
Right, I put a semicolon on the end because these functions they're anonymous functions on the right side here of an assignment. This is what we call a function expression. And so we know that other assignment expressions get semicolons after them, like if we do var x equals 1, we'd put a semicolon after that. Same thing here, right? We're saying add task equals some function, semicolon. However, if this function were a standalone, right? If this wasn't part of the prototype and it was just called like add task, right? Then we have to remove that semicolon. All right, does anybody have any questions about this? Actually, let's go ahead and look at what this would look like in the console. Just so we are clear. So I'm gonna refresh this just to get a new. All right, so I'm gonna just put this constructor and the prototype definition, my whole class definition into the console. So now I've got a good definition here. So now I can say var my to-do list. I'm going to create an instance of this class is a new to-do list. And we know that this constructor takes a tasks array, which we'll assume is an array. And I'll just say like, you know, go to the store, comma, do homework, and that's it for now. Okay. So I'm just passing this array in as the tasks argument to that constructor. So now that I've created that, if I take a look at my to-do list, I'll see it's an instance of the to-do list class that has a tasks key, which is an array of strings, right? An array of task strings. Now, I also happen to know that this my to-do list has, oops, what did I just do? Because we defined it in the prototype, it has a name, even though it doesn't show it here. Because it's in the prototype, we know it has a name. We also know that it has a method called log tasks. So I can call that method, my to-do list.log tasks, parentheses, to call the method. And I'll see, go to the store, do homework, log to the console. Yeah, it is so cool. You're right. Okay, now any more questions? We're at another good breaking point. So if there's any more questions on this material, I'll answer them. If not, we'll go ahead and break, come back, and we'll talk about this in more detail. Yeah. Yeah. Yep. More questions? Okay, let's take a break and we'll come back and we'll round this out. Hey. Yeah, totally.
I saw it. I made the GitHub page for it. Put it up there. Do I share the link with you?
Yeah, I haven't made a submission for it yet, so if you just Slack it to me.
If I just Slack,
I do. I
like
just
the link to my repository.
Yeah, that's great.
So it's like public.
Yeah, it's public unless you paid for GitHub, which I now you have. You don't have the ability to make private repos.
Okay.
Cool.
I think there's a shitload of code that I could have made way more efficient. You guys was just kind of banging it
Stretch
out.
goal
Yeah.
later on, next iteration.
Cool. And will the
He's
final
definitely one
possibly you can screenshot the
Yeah, I'm gonna record that part. I might not record the presentation, it's just because I don't.
No, yeah, that's totally fine.
But I will record that part. So.
Okay. Cool. I'll Slack this to you then.
Thank you.
I don't understand where they're coming from.
just spent a lot of time with them.
House or?
Oh, and we were like, we did like, no, I was in Seattle, so here. That was the one place we could because 3 hours out. Well, that was like not the best experience, but it's just it's very much like it's there's one now. Oh. Yeah.
This thing, like this is what we were doing.
Yeah.
So I had to like jump off this like thing up way high.
Oh my god.
And then I slammed into this thing.
Whoa.
It's almost like you were bungee jumping a little bit. 'Cause
Were you
of the
holding
drop.
like were you harnessed?
Yeah, so like they have like super harnesses on us, and basically, obviously, we're tied to all these things.
That's
And you
awesome.
have like 3, like at least 2 clips all the time, and now it's just 3. So it's pretty cool.
Did you watch that guy jump out of the plane without a parachute?
Yeah, I saw that.
You're almost there.
I know, I know. They gave me like heart pounding.
It was scary.
And then he had to flip on his back.
Yeah, and he was practicing.
Yeah,
That
I
was
saw him. Yeah,
cool.
cool.
What's up?
How did you go about templating a grid?
In like handlebars or something?
Yeah.
It depends on like, what are you putting in the grid? Is this like a textual grid or is it like a?
Yeah, so with like on-hover, unique on-hover stuff. I want a grid that has a title, and then when you hover over the title, it gives a description of the item.
So probably what you do is 2 nested for eaches, right? So you do an each for columns and then inside that an each for row, right? And you plot one after another based on some nested arrays that way, right? So you'd represent your grid as an array with arrays in each slot, right? So this the outer array at index 0 is the first column or the first row, and that's another array. So then you loop through this top array, and as you got to each one, you loop through the second array. So it's kind of hard to describe in words, but the way you're going to do is with nested arrays and nested for each loops.
So basically, I would give each item its own unique array number. So like array row 0 for all the top rows ones.
Exactly.
And then column 1.
Column 1 would be like the first thing inside of that array.
Okay.
Yeah. Hey.
Do you have a suggestion of how to
That's
detect
right.
a mobile device?
Called your bomb.
There are a lot of ways to do it.
I'm working on my Squarespace site, and I know that iPhone red displays like with double pixels, so I can set like an embarrassing value on it.
Yeah, I mean, so the way that most people do is by using what's called the user agent. So it's like part of the document global thing, or maybe part of the window probably. It'll have like what's called a user agent. And you can find online like regular expressions that can parse those user agents to tell you like, is this a mobile device, is it a tablet? That's the way most people do it. But there are other ways to do it. You can also just detect, is this a white device that has twice the width? So if that's your specific concern, then I would look up. Probably, yeah. Probably so. Yeah, because like it's probably stored as some sort of part of the global window object. Its resolution, whatever, its pixel density, whatever it is. So, yeah. Mm-hmm.
She's using MailChimp and Context.
Okay, let's keep going. questions about this while you're on your walk to the water fountain? No? Yes? Okay. Maybe they'll come up later. All right, so the next thing we're going to talk about is we're going to look more into this keyword. So we've seen it now in two different lights. One, we saw it in sort of this jQuery event listener world, where this is representing the HTML element that was clicked on, right, inside of those event listeners. And now we've seen it inside of constructors, where this is representing the new object that's created by the constructor. Okay? So there are some rules to figuring out what exactly this means in different contexts, as we'll call it. Okay? Now, these rules are many, and they are probably hard to absorb all at once, but I'm going to tell them to you, and we're going to look at some examples. But the key thing I want you to take away from this, dramatic pause. The key thing I want you to take away from this is that this, the keyword this, and what it means depends on how the function was called. So when we are defining a function, we don't know for sure what this is. When we are defining a function, even say when we're defining a constructor function, we don't know what this is. We can assume what this is. In the case of a constructor, we assume it's the new object being created, but we don't know. We don't know what this is until the function is called. And based on how it's called, determines what this means. Okay, so that's the main takeaway. Now, let's get into what the actual rules are. Okay, so here's sort of 5 rules that I kind of made to kind of group the different contexts where this might mean something different. So starting at the top, if we're not inside of a function, this refers to what we call the global object. Okay. So in your browser, there's a global object called window, and that global object is where all of the global variables are stored. So if we open up our inspector, if I type in window to the console, what I'll see here is there's a huge object that has all of the global variables in it. So anytime we define a global variable, it gets put into this global object called window. Okay. And if we are not inside of a function, this refers to that global object. Okay, so that's rule number 1. If you are not inside of a function, this refers to the global object. Yes? There is. If you're working in Node, the global object operates the same way. It's just called global instead of window. It has the name global instead of window, but it operates the same way.
So if you use like window.load, that's the same, like, is that of this dot load? Or?
If you're not in a function, because remember, because this only means window, the global object, if we're not in a function. Okay. All right. And in some other situations, which we'll discuss next. If, okay, number 2. Number 1 we got, right? If it's not inside of a function, if we look around, we're not in a function, this means the global object, without question. If a function call, okay, if a function call, remember how we call a function? We say the name of the function, and then we use parentheses. If a function call has no dot to the left of it, I'll show you what I mean by that. If the function call has no dot to the left of it, this still refers to the global object, window, or global in Node. Okay? That's rule number 2. Rule number 3, the most common scenario, if a function call has a dot to the left of it, And what I mean by that, let me just illustrate so we can see what I mean. If we call a function my func, no dot to the left of this function call, this is the global object. If, however, I said my obj dot my func, this is the object to the left of this dot. In other words, my obj. Okay. So again, it depends on how that function is called, whether or not, depends on how it's called, what this is. In other words, the context in which the function was called. Okay, let's keep going down. We'll see some concrete. What? Immediately to the left of the dot. The window. Exactly. It's a great way to think about it. Okay, number 4. If we are inside of a constructor function and we use the new keyword, this is what we've been doing all today, right? If we're inside of a constructor and we use the new keyword, this refers to the new object that's being created. So that's number 4. If we're inside of a constructor function and we use that new keyword, very important that we use the new keyword, then this refers to the new object being created. Okay. However, even if we know all of these rules, this can be manipulated. This can be changed using some pretty advanced JavaScript techniques. And that is how jQuery manages to make this the element that you clicked on. jQuery is doing something inside of its library that's actually manipulating what this is manually. So we're not going to go into too much detail. I'll show you the methods that are used to do that. But I'm not going to go into too much detail about how they work because that's really advanced stuff. Yeah.
So, like, the people who made jQuery, I guess the logic would have been like, it's really easy to call Windows, so like, why not use this or something else?
Right. They just decided to use this as a convenience, really. And it's one that makes a lot of sense in the context of jQuery. However, it does kind of skew how we think about this because it doesn't really follow all these rules that we know about. Okay, so let's look at each of these individually. So again, if we're not inside of a function and we use this keyword outside of a function, what is it? Well, it's the window. Or the global, if we're in Node, the global object. Okay, looking at number 2. If a function, like I just showed, has no dot to the left when we call it, if it has no dot to the left when we call it, this is still the global object. So here we're defining this function. Inside of that function, we're logging this. Here, when we call this function, there's no dot to the left. So this, when we call it, is the window still. Okay, so notice, when we write this function, we don't necessarily know what this is because it all depends on how that function is called. If it's called this way, this will be the window. If this function is stored inside of an object and called with the dot to the left of it, then all of a sudden what this is might change. Or will change, not might. So let's look at an example where we do have a new this context. Number 3, if a function call has a dot to the left, this refers to the object before the dot. So here we're defining a variable myObject and storing in it a JavaScript object. At the key A, we have the number 4, and at the key B, we have a function. And this function logs this. If we call myObj.b, because there's this dot to the left of the function, this becomes my object. And so when we console log this inside of that function, what do we get? Well, we get this object. A is 4, B is a function. Right? So this, when there is a dot to the left, becomes this thing to the left of that dot, the object to the left of that dot. We've seen this all night, so I'm not going to dwell on this, but when we use the new keyword in front of a constructor function, like the person, what we'll get is a new object that's being created. So the new instance that's being created by that constructor. So if I were to log this inside of that constructor, what would I see? Well, I'd see my new person object with that name. Okay, and then finally, just briefly, I'm going to mention these things. There are methods. Remember that a function itself is an object. And those objects have methods called bind, call, and apply. And these three methods can manipulate what the this context is. They can change what this is. So it's possible for us to make this something completely different if we wanted it to. And there are some situations, in weird cases where you might need to do that, but generally, this is not something one need on a day-to-day basis. At least not yet. Okay, so what I'm going to do is I'm going to show you some examples that kind of use these rules, maybe build on a few things, and we're going to talk about what is this in these various situations. All right, so here's the first one. Take a minute to look at these. At each of these, I want you to just take a second to absorb it, think it through, and then I'll ask if anybody can help me with the answer. So take a second here to think it through. Okay, so if I console log model.b, what would I get in this situation? Exactly right. Can you tell me why? No, that's it. You just hit on it. Not even a function, right? There is no function here. We're outside of a function. There's no function definition in sight. And thus, this is the window. Does that make sense? If there's no function definition in sight, if we're not calling a function, then this is the window. That's just what it is. That one is invariable. Okay? Take a second to look at this. All right, so when I call this function, what will I see in the console?
Name Jacob. Log this function.
Exactly. When I log this to the console, I'm going to see this entire object. And the reason for that is when I'm calling that function, there's a dot to the left, and that dot is this person variable. In other words, this person object. Okay? So this becomes this person object when this dot here has a person to the left. Take a look at this one. This is where it gets fun. Okay, who wants to guess or tell me what this is, or what I would see in the console when I ran this function.
hole.
Mind bender.
Just gonna say black hole.
It's not a black hole. Anybody? Undefined, not a bad guess. All right, so here we're calling a function. That function we know is defined up here. Because we're doing this log this, we're storing that log this function, this variable b, and here we're calling it. Oh, all right. Let me ask you a very leading question. Is there a dot to the left when we call this function? No. There's no dot to the left when we call this function. So what do we know about this when there's no dot to the left when the function is called? It's the window. So if we were to call B here with no dot to the left, this is now the window. And we would see the window logged to the console. Right? So again, it's the same function, but we've called it here with nothing to the left, and in the previous example, with person to the left. So this is only dependent on how the function was called, not where it was defined, not where it's stored. None of those things matter. The thing that matters is how it was called. In this case, it was called with nothing to the left. So this is window. Okay, let's look at another example. This one's a little more code, so I'll give you a second to kind of soak this in. Okay, when we run lion.make sound, what will we see in the console? When I run lion.make sound, what will I see in the console?
More.
I will see roar exclamation point. Okay, and the reason we know that is because we're calling make sound here. To the left, there's a dot. So lion, the lion object, which is an instance of this animal class, will become this. We know that when we created this class, we set the sound equal to roar by passing it into the constructor. And so when we call this function, lion is this lion is this, lion.sound is roar, and so we'll get roar exclamation point. The reason for that is not because it's part of the prototype. The reason for that is because lion is to the left of the dot. See that? The only reason that make sound knows what this is inside of this prototype is because lion is to the left of that dot.
What if we didn't have this var lion line and you had lion.make sound? What would happen? Would it come back undefined, or would it default to
If I
this?
didn't have this,
Yeah.
then I would get a reference error.
I saw
At
there would be
line.
like, okay.
There'd be a reference error at lion because that thing's not defined. So my whole JavaScript would just break.
And if you just said make sound.
If I would also get a reference error
Oh, yeah,
because there's
because
no
that's
there's
part
no
of it.
function called make sound as part of this prototype. Yep. No, it's okay. It's good to think those things through. Okay, let's look at another one. Is this different? Did I just have the same thing twice? I did. Well, that's weird. Okay, let's look at this one then. I could have sworn I changed something about that one, but apparently not. So let's take a look at this example. Soak this one in. We're not using this make sound in this example. But what I'm asking about is this line here. What's going on in this line here? Can anybody tell me how this line differs from that line in this code? Yeah.
It's not calling on the sign new function.
We've left out, notice, the new keyword. So on this one, when we're creating that, we're using that animal constructor, we're using this new keyword. On this one, we've maybe accidentally left out that new keyword. Okay. So what happens here? What's that? Yes. Remember, if we call a function, no dot to the left, no new keyword, this is window. And what we're doing, not what we intend to do, is we're creating two global variables, one called name and one called sound, and putting these two things in the global scope, right? Window.name. Okay. So if we forget this new keyword, what we're actually doing is creating some global variables. We're not actually creating a new instance of anything. And as it happens, this also won't return anything. So lion here will be undefined because we didn't use that new keyword. I've got one more. Questions about this one before I move on to the next one? Now, if you thought these were hard, this one is the hardest yet. So get ready to, ramp up your brain. And it's not going to be immediately obvious either. So you're going to have to really think about this. So here we go. We've got the same class, same make sound thing we're defining on the prototype. We're creating an instance. We haven't forgotten the new keyword. Everything up until this point looking pretty good. Down here, we're running jQuery.get. We're making an AJAX request to some endpoint called /animals. And as the callback function, the thing we want to do after that AJAX request completes is we want to run this function lion.makeSound. What will happen when we run lion.makeSound as the callback? We can start with this. What will this be when that callback function runs? Good guess, but no. Good guess as well, but no.
Why are you running the call? That's the callback function.
Mm-hmm.
There's no click.
No,
Right?
it's an AJAX request.
Okay, so
Ignore the fact that this is jQuery. Think of this as generic asynchronous function that has a callback. So ignore the fact that this is jQuery.get, and just think about this as an asynchronous function that needs a callback function. What happens when we try to call that callback function? What will this be? So that's what you're saying. What will this be? Will be sound exclusion. It's not a bad guess. Okay, so I didn't really expect anybody to get this because that would be kind of crazy if you were able to get there on your own. But let me kind of sort of walk you through what's happening here. So again, remember, I wanted you to think of this as generic asynchronous function, not necessarily jQuery.get. It could be some other asynchronous function like remember game prompt we used in one of the early projects. Some of you have probably encountered something like set timeout or set interval. Those are asynchronous functions in your projects if you've seen those. So basically, this is an asynchronous function, so we need to pass it a callback function. Right? So when we do that, we're creating, when we define that asynchronous function, we define a parameter. Say we call it callback. That's generally what people call it, and it's standing for a callback function. When, at the end of this function, we do something async, and at the end, we call that callback, notice what's to the left. Nothing. Nothing is to the left. And thus, this is what? It's the window, right? So even if we say do something async and pass it this.myfunc, this is going to become callback. And when it gets called, there's nothing to the left. And this will be the window. So I'll ask you again, if we were to do this example, what would we see in the console? So this would be window. When line.makeSound is called as the callback, this would be the window. Yes, and unless there's some global variable called sound, which there probably is not, we'd see undefined exclamation point. So you may encounter this at some point, you're like, why isn't this happening the way I expect it to? And the reason is because you're not calling this function here, you're not setting this at this point. This gets set later inside that function when it's actually called. And at that point, it's lost the context. Now, you're thinking, what if I want to keep the context? There is a way to do that, and the way you would do that is by using those bind, call, and apply functions that we talked about earlier to manipulate the context. But I'm not going to go into all that. Okay. So this is a pretty thorough introduction to this. It is not the complete, this Bible, right? There's still some nuances, and obviously we didn't talk about like how to manipulate this and other things like that. But this is enough so that you are, you understand pretty well what it means in normal circumstances. And I encourage you to go back and watch this again, and really let it soak in, because these rules are not exactly obvious. This is probably one of the hardest concepts of JavaScript, is the this keyword. This is the thing that, I interview people, JavaScript developers all the time, and I grill them on this. I don't think I've ever had an interviewee that fully understood how this works. So, if you can at least, get a pretty good understanding of this, that's a huge step in the right direction. Okay, we have one more topic to talk about. And that is called closures. Okay, so another sort of JavaScript big idea. Once again, sort of an introduction to this topic, not a complete anthology or whatever. But basically what a closure is and what a closure means, at the root of it means that a JavaScript function remembers the scope where it was created, where it was defined. Okay. So a JavaScript function, even if it gets assigned to some value and moves all around your program, it will remember the scope that it was created in. So we remember that we have a global scope that stores all of our global variables. And each function that we define creates a local scope. And local, we can look out from local scopes, from a local scope to a global scope, or from a local scope to another local scope. We cannot look into a function scope. Those are, we can't, if we define a function, add to do or whatever, if I'm outside of that function, I can't look inside of there and see what's going on, see what variables are defined. However, a function will remember the scope that it was created in. So let's see what that looks like. So this is some code that's not unfamiliar. You totally know what's going on here. I've defined a function called closure example. Inside of that function, I've created a variable, name equals Jacob. I always use my own name, so silly. I've also defined another function inside of this function. Okay? And then at the end, I'm calling that function that I defined there. So if I were to call this closure example function, what I'd see in the console is my name, Jacob. Everybody cool with this code? Okay. What if we change it to this? What would happen? Okay, so what I've done is I'm now defining this variable here, and I'm defining this function, but I'm not calling that function log name anymore. I've removed that part. I've removed this calling of log name from that function. So here I'll call closure example. What will happen when I call closure example? The outer function here. What's that? It'll go through, but what will it do? Will I see anything in the console?
Yes.
What will I see in the console?
Jacob.
Okay. So where am I seeing Jacob? I've defined this function here. Where am I calling?
Inside closure example.
Am I? Do you see log name parentheses?
Are you talking about log name or closure example?
So notice in this one, inside of this function, I'm calling log name. So that's what I see.
No,
in the
you won't
console.
see. You won't see.
Right, correct. Exactly. When I call closure example, all I'm doing is defining stuff.
Yeah.
So I won't see anything in the console. I'm just defining a variable, and I'm defining a function. Right? Nothing's being logged, no action is actually taking place other than defining stuff. So closure example, I'll see nothing in the console, or maybe I'll see undefined. What happens right here if I try to call this log name function? I'll get what? Undefined. Actually, it'll be worse. I'll get a reference error. And the reason for that is this log name function is defined inside of this local scope. Okay? So I can't see from out here, I can't see what's going on in there. Right? I can't look into local scope. So log name is not even declared. Thus, I'll get a reference error here. Yeah.
It's the only way you can pull out log name is if you return log name and something else.
You're warm. You are very warm. We'll see that in just a second. Okay, likewise, what would happen if I just tried to console log name right here? Console log the variable name right here, outside of that closure example function. Exactly, precisely. It also will fail. I'll also get a reference error because name, again, is defined inside of the local scope of closure example. So I can't look in there, so I can't log the values that are inside of there from outside of the function. Okay, well, what if we do want to sort of access that name variable in some way? We want to log that name variable to the console from outside of that function. Well, we can do that like this. Okay. So here, instead of just defining these two things, we're also going to return this function. This log name function, I've removed its name, just made it an anonymous function. We could have left it, no reason not to, but I've just, instead of defining it, I'm also returning that function value from this function. So down here on this line, when I call closure example, the return value is this function which I'll store in this log name variable. Okay, so far so good. We've just called this function, returns this function, log name. Okay, let's scroll down a bit. Now, if I call log name, what do you think I will get? If I call this log name function that was returned from closure example, what do you think I will get? I heard somebody say it. I'll get Jacob. Okay? And the reason I'll get Jacob is because this function remembers the scope from where it was defined. This function was defined here. It remembers this local scope, and it can still see this variable Jacob. And we call this a closure. So this function here, even though it's now out here, even though it's been returned from that outer function, even though it's been returned and it's now in this variable log name, it still remembers the scope from where it was defined. And so it can remember where this Jacob is, and it can log that Jacob to the console. So when we run that log name, we'll see Jacob in the console. What will happen if we try to log that name variable directly? I see some heads shaking, right? We're still going to get a reference error because that name variable is still defined in this local scope. We still can't access it. Okay? So we have very limited access to the value of that variable by using this log name function. We can access it in order to just log it to the console. We can't access it directly. For instance, we can't change its value. From out here, there's no way to change the value of name. Okay. So we have very limited access. We have restricted access to that name variable in only the way that this function defines. So herein lies the reason why we might use closures. If we have some data that we want to restrict access to, we can use closures to do that. So now we can access that name variable, but we can only do so in structured, defined ways. In this case, we only have the ability to log it to the console. We don't have permission or the ability to change it or to reverse it or anything else other than log it to the console. Okay. So we've created this closure in order to protect that name variable from being manipulated. Question?
How is this useful outside of a server browser interaction? Especially since, like, theoretically, you would put this in a script that you're adding to a web page, but any script that's in the browser is manipulatable, regardless of the closure scope.
Yeah, absolutely. Right.
So what is the true purpose?
So probably the best use case for this, right, is if you are creating a JavaScript library. So if I'm creating jQuery, say, jQuery has a bunch of internal variables that it doesn't want to expose to you and doesn't want to let you modify. Because if you do, it's going to break jQuery. And because it wants to protect those internal variables, it's going to put them inside of a closure that you don't have access to outside of the jQuery file.
So is it just about scope limiting, really?
Exactly.
So just in case.
And there's nothing to stop you from downloading jQuery, opening it in a text editor, and manually changing it. Nothing to stop you from doing that. But you couldn't do that from anywhere else in your JavaScript.
It's just protect variable scope, so you don't happen upon using sound happens to be a global variable.
Correct. Okay, so let's go ahead and, that's what I just said. Let's go ahead and do a quick exercise to sort of put this into practice, okay? And actually this one we'll do as a code along because it takes this and it builds on it a bit. So we'll go down here to number 8, okay? And if we take a look at number 8, what we see is we have 2 global variables and 3 global functions, right? So these 2 global variables, tasks and list name, and these 3 global functions, get tasks, get name, and add task, okay? Now, anywhere in our code, we could modify tasks and list name, anywhere in the code, because those 2 things are global. Everybody has ability to see those 2 variables, right? That was sort of the definition of a global variable, is that everybody has access to it, anywhere in the code. But that might not be ideal. Maybe we want to control the way that array, that tasks array, is interacted with. Maybe we only want to let people get them and see what they are, or add one to it. We don't want to let people say reverse it or sort it or whatever it might be. We don't want to let just unrestricted access to this like it is now. We want to restrict the access to just these functions. Okay, so let's do that. And the way we're going to do that is we're going to create a closure. I'm going to just leave these here and work below them. Oh, I'm sorry, my screen is all weird. Let me fix that real quick. Come on. Better. Better? Cool. All right, so let's create a function in order to hold this closure. Right? In order to create this closure, we need a function. That's how we create a closure. In the previous example we looked at, that function was called closure example. Here, I'm going to call it make to-do list. Okay? And inside of this make to-do list, I'm going to take these two things that used to be global variables, and I'm going to make them local variables that only exist in this scope. Okay. Now, before, we returned a single function, right? And that single function had access, because it was created in this scope, it had access to these two variables. Does anybody have any idea how we might return 3 functions instead of just 1? Because now we have 3 functions that need access to that local scope. How might we do that? Yeah, totally. We'll put them in an object. So let's do that. Let's put them in an object. I'm going to just return a new object, curly braces. And I'm going to make each of these functions a property in this object. So I will say get tasks. There's a key get tasks, and the value is this function. Notice I could make this anonymous, but I don't have to. This time I'm going to leave the name there. I'm going to create a get name key. And I'm going to store as the value of that key this function. Oops. And then finally, an add task key that has as the value this function. Okay? So now, when we return this object, each of these functions is going to remember the local scope in which they were created. And they're going to remember this tasks and list name variable. And so anytime we call them, they will have access to those variables. But if on this line we want to reverse the tasks array, we no longer can. We don't have access to that anymore because the scope is limited to this function. So just to visualize, I can create a variable. My to-do list is equal to make to-do list. Okay. If I want to interact with that tasks array, the only way I can interact with it is by using one of these 3 functions. So I could add a task by saying my to-do list dot add task, and then pass it, go to the store. And that would update a to-do list array, or a task array, and add that new string. However, I couldn't say tasks push go to store. This line of code, no go. I don't have access to this tasks variable anymore. It's not global. I'm not, at this point on line 173, I don't have the ability to look inside of that function. So this line will not work. Okay, you may be thinking to yourself, this looks a lot like those functions that we were changing to turn into objects, right? So I don't know if you're thinking that or not. Maybe you are. Remember, throughout this lesson, we had these make functions that we turned into class definitions. So we could turn this into a class definition. And quickly, I will show you what that looks like. So we're running low on time here. But if we wanted to use classes and object-oriented programming to do this instead of just creating a make to-do list function, we could do that by first, well, we have to define a constructor. This time, we're not accepting any input. We're just starting everybody with an empty array, which is fine. Okay. So we'll go ahead and say, what we've done in the past is we've said this dot tasks equals, like array or whatever it might be. This is what we've done in the past. But the problem with this, if we want to restrict access to tasks, when we call this constructor, we have full access to tasks because it's part of that new object. Okay? So if I were to call, just to illustrate what I'm talking about, if I were to call my to-do list is a new to-do list, if we do it this way, I have access, full access to that to-do list task by doing this, right? So if I wanted to push something in there, I could directly. But I haven't restricted access to this thing. So the way that I'm going to restrict access is instead of assigning this and this, I'm going to create a variable. Okay. This variable is scoped to this constructor function, and it can't escape out of that scope. Now we have an issue. In previous examples, we would have added these functions by doing prototype to-do list dot prototype add task is equal to a function, and we would have said this dot tasks dot push, right? However, will this work now? It won't work because tasks is never added to the instance object. It's just a local variable created in the scope. So how do we get around that? Well, we're going to revert to storing function here. So now, this new to-do list will have a property add task, but this function now remembers this scope in which it was created, and thus still has access to this tasks variable. So we may think this function is the same for every instance, but in fact, it isn't the same. It's subtly different, and the difference is the scope in which it was created. So that's why we have to move it into this, into the constructor, because it needs to remember this variable task. So if you come from another language, say something like Java or C++ or something of that nature, we have the concept of what we call public properties and private properties. Properties that you want other people to have access to, which is what happens when we put it on the prototype or when we add it to the this. And you have private properties, or properties that you don't want others to have access to. And we can create something like a private property by using a closure to restrict the access to something. Now, this is not as common as everything we've seen up until this point. This is much less common to do it this way, to have these private properties. But it's an important concept, something you should know. We see this method a lot more frequently. All right, final questions?
It's kind of like public static void.
Yeah, each of those words has a special meaning, but yeah. Okay, this was a whirlwind. What we're going to do next class is we're going to actually take all of these principles and we're going to apply it to an exercise. That will be like about half the class period. Kind of taking these things and using it to refactor a completely functional application using the principles of object-oriented programming, enclosures, and things of that nature. I'm actually not going to be here this Thursday. I will be in Colorado for work stuff, sadly. But I'll leave you in the very capable hands of Paul and Lauren, and they're going to sort of lead the exercise. And then after that, we're going to do like a brief review from all the way back to the beginning. So we'll look at different concepts throughout the course and kind of see maybe more advanced applications of those principles. Okay. Any other questions? Remember that this is the penultimate week of this class. Next week is the last week of class, and your final project will be due a week from Thursday. We'll be doing presentations, and we'll have food and fun, and it'll be a whole good time. A week from today, we will have a 3-hour-long lab period where you can work on your final project with full access to all of the instructors. Okay. Sound good?
Are we supposed to present our projects to the class?
Yes, on Thursday, a week from Thursday, we will do presentation, short presentation, 5 minutes or so. I may ask you a couple questions about it to kind of guide it. Nothing too fancy or too prepared is necessary. We just want to see what you've been working on. Any more questions? Please fill out the exit ticket before you leave, and I will see you on Monday when I have office hours if you choose to come.
Yeah, it was more time. Yeah. It came in, so this is on the triple. So there was that triple down, and there's a triple site. It's a triple site.
So that's why it was a preference.
I mean, I didn't design the front end, but I think it's not the worst site, except for this part here. This needs to be full.
Okay. All right. Let's do this. Let's do this.
Nothing. I just helped the maintenance. That's the back.
You know what's a good looking site? Back.
Better markets.
Yeah. Oh look, everything's modern according to like what appears to be a pseudo material format display. That looks like it was built in the mid-2000s.
It's fine.
That's like you built.
No. It's not even. It's not even.
No. Master Overwatch. This side.
Oh yeah. So yeah, I mean, I have it on my phone, and I'm probably gonna be online most of the time anyway. Yeah, I'm accessible.
I don't know. It's definitely JavaScript and I think
It'll be
part of
fun.
the API.
Yes.
It'll be well, actually, the time for you to.
Hopefully, yeah. Unless I go all out at the hackathon. Sometimes I do.
Yeah.
And I do the whole 24-hour thing.
There.
Yeah. I don't really have an idea yet, so
Yeah.
I'm not sure if I'm gonna get that intense.
I'm sorry.
As an employee, can you wait?
Can-
Hackathon?
Yeah. I mean, yeah, they're internal.
Oh, it's all internal.
Yeah, yeah.
Okay.
Yeah.
Okay.
Yeah. So we have like internal things, and then like we have like a popular vote, which is like the big thing.
Okay.
And then there's like the CEO gives an award, the CTO gives an award, the director of UX gives an award. Yeah, it's really fun.
I guess that's what you can do. You can host it
Yeah, I
internally.
mean, we did it when we were just at this.
Yeah.
Which is like 100 or so people. And that's actually where this came from. They saw us doing it, and they're like, oh, we should do this
Okay.
for everybody.
Dario's really good.
It's pretty neat.
Yeah, that's actually really cool.
And a lot of our like awesome product ideas are coming out of that. Hey, thank you. Have a good week. See you next week.
Leaving already?
She said she's waiting for you outside.
It's really cool. I think we have GA apparently took one in the past,
But that's one of my favorites.
it's so hard wrangling
Yeah.
students
But yeah, no, totally.
versus like people who
Paid employees
Yeah,
who
exactly.
have to show up.
who don't have
Anything better to do.
anything better to do.
Yeah.
So I don't know.
And it
But
helps.
we're hosting our